Well, good afternoon, everybody. It's another Love My Tool TV session with the great folks at Ixia. And today we're going to talk about visibility, and best practices. And to me, as an old guy who's been around the industry for a long time, if you can't see the data, you're never going to know what's going on or not going on in your network. So visibility, true visibility, is important. And so we got Rajette today who's going to talk about it. We got our old friend Keith back. And of course, the master of ceremonies, Denny Mew. So Denny, take it away.
Okay, yeah, thank you, Tim. And by the way, just want to remind everyone that this is the first of a 4-part series on network best practices of network monitoring. We kind of did two prequel already. We did one on TAP, and then we did one on TAP versus span port. So today we're kind of going back to my old stomping ground and talk about something that is about link aggregation or whatever name that they use nowadays. So I'm going to turn this over to Keith for a minute and let him introduce today's topic and as well as his new colleague. Hi, Keith.
Yeah, hi, Denny. How you doing? Hey, everybody. So yeah, what we want to talk today about was visibility architectures. What are they, and how do you use them and stuff? Because like when I go out and I talk to people, they're like, oh, I've got my great security architecture. I've got this IPS. I've got a DLP. I've got my a web application firewall. I've got all this great stuff. I've got a secure network and all that. But in reality, we all know that's not true. We've seen many instances in the press lately and over the last several years where just because you have great security tools doesn't mean you're really that secure. As Tim talked about, it's about the data. You've got to have good data. You've got to capture it where you need to on your network. You've got to filter it and send the right data to the right tools so you can get the right results. So that's where we wanted to step back and talk about visibility architectures today. And to help me out, I've got Rajette Ozdag. He's our Vice President of Product Management. He's going to step in and talk to us about packet brokers and visibility and stuff as well.
Yeah, I just want to emphasize what Keith said. It's the same as getting to the latest version of Microsoft Word doesn't make you a good writer.
Yeah, exactly.
It's interesting because one of when we commonly ask network admins or data center admins, hey, how many tools do you have, or how do you connect these tools, IPS, IDS, firewall, other application performance monitoring tools, they'll have an answer, but typically it's an ad hoc answer. It's not something that they really truly thought of. They thought, oh, well, I'll just connect it here. I'll just connect it there. But they haven't really thought of, well, am I accessing all the data? Am I able to send all the data, all the important data to these tools for monitoring? And so typically you'll realize that they understand that visibility and the ability to monitor is important. They just haven't thought of what is the foundation? How can I come up with a foolproof method so that when I connect my tools, I get the right information to the right tools? And this is really where the visibility or the monitoring fabric comes into play, and it's really end-to-end visibility or fabric. So you need something of a foundation which allows you to connect these tools. And remember, you can upgrade these tools too. So if you have an IDS and you need to upgrade it, how do you upgrade it with minimal service time? It's very interesting. If you haven't thought about it, they get surprised when we present our architecture, which essentially is a structured framework that consists of taps, switches, network packet brokers, and their virtual equivalents. It's like electrical outlets that you can connect all your tools. It's really essentially that's what it boils down to. You're building a house. You don't put the electrical outlets there, and then all of a sudden you have your microwave, and there's no way to connect it, right? It's kind of like that. So that wiring as well as the plugs. That's really what the visibility architecture is. It allows you to connect your tools to the network. That's what we'll talk about. But it's very interesting that once you bring this up, though, it's like an aha moment. Oh, I get it. Of course this makes sense. But until you bring it up, it's always this pain point, and they feel like maybe it's a pain that they encounter, and there's no proper solution. But there is a solution.
I wonder if I could
problem.
turn to Tim for a minute and kind of give a little bit of a historical perspective on visibility. But in the meantime, Rejab, I wonder if you could go up to where you see all the icons. And
Yes.
there are two things you can do. One is that there is something called a bandwidth usage. If you dial back the bandwidth usage, or when you speak, you can just like turn off the video camera, then it will improve the audio quality. We have a little bit of problem today, so let's just see if we can fix that. I know for sure that if you turn off your video camera, then you're not using any bandwidth, then your audio should come out better. Tim, take it away for a minute. Why Rejab is fixing his computer.
Well, it's like a doctor. We've tried video medicine and hasn't worked real good because doctors need to be right in front of the patient, have total contact with the patient. When you're trying to troubleshoot, and people talk about taps as if they just started coming out a few months ago. And Network General, the original sniffer company, we built the first LAN tabs, a company called Datacom, and we built them back in the early 90s, like 93 to 95. And it was a whole new world of visibility. But back in the 70s, we built taps that allowed you to look at RS-232, V35, which are WAN connections. And the neat thing about today is the technology and the ability to focus the data to the right tool, like Keith mentioned. Being able to get everything into a device that says, hey, I'm going to send my application data to this device that measures application performance. I'm going to send more data to my security devices, to my voice over IP, video or IP monitoring devices. And it really is cool now today because we can go so much further. And of course, now with 10 gigs, 40 gigs, and 100 gigs, that's like trying to drink from a fire hose. It's a 4-inch fire hose. And that's where getting everything, being able to, and especially, Keith, I mentioned this to you a few times. If you're going to use a device for security reasons, make sure that it's not a device that can be hacked and alter your view.
Yeah, exactly.
There's only one device.
Yeah, exactly.
There's only one device that will do that.
And to your point, with the fire hose example, you put the tap in, you get all this data coming at your tools. You really need to step it down. They can't handle all of this data bandwidth coming at them. So you really need to, with the filtering process, step it down so that it ends up being a garden hose worth of data coming at them, not a big fire hydrant or fire hose of just data that just annihilates the tool.
Yeah,
that's right.
well,
So the step one is really to make sure that you access data everywhere, right? The principle is that access data wherever it is. So tapping everything is step one. Now remember, with virtualization and particularly with VM-to-VM communication that just resides on the server, there's some communication that never leaves the server. So you also need virtual taps, because malicious code could be in virtual machines, could be in containers, or it can be malicious code, or just want to understand why is my server performing poorly. So first step is really to use taps, and there's a tap for everything. Copper taps, fiber taps for all bandwidth. And then, of course, make sure that you have your virtual taps, and virtual taps can be available for VMware as well as KVM and OpenStack. And in fact, there's even taps for cloud, public cloud, starting with Amazon. So we're seeing those too. So but now, of course, all that information, all that data, there's a lot of data, and that's what Keith was alluding to. Now, the tools that you have probably are limited in terms of bandwidth. You can't possibly send all that data to your tools. So you need to essentially groom them, filter them, understand what you want to send. Maybe you just want to send data based on layer 2 or layer 3 information, maybe just certain VLANs. Or maybe you want to send application data. Maybe you just want to send your Salesforce data or your data that the financial department uses. Maybe you don't really care to send, or through an intrusion detection system, data that is related to Netflix. Somebody's streaming a video, who cares? So you have to be able to do filtering from the packet layer all the way to the application layer, so you can groom that data and send what is really important.
Yeah.
And that's where, yeah, go ahead, Keith.
I was going to say, yeah, that's the important thing. It's like, okay, so what do I have? What do I need? How am I going to get there? So you've got to have the data access. You've got to have the filtering. You've got to have the plan. Is it packet data? Is it flow data? What are you looking at? What do you need it to do? That's where we come about it when we talk about this architecture. You let everybody talk about a security architecture, and I've got my tools here, tools there. You need to take the same amount of time for your visibility architecture, because that data and that quality of the data is what's going to be fed to your tools and what's going to help you as far as coming to resolution for security alerts and security breaches. It'll help you determine what's real, what's not, and if there is a real breach, where is it? How fast can you get to isolation of it, and then mitigation of it?
Is this
data leak.
description, is this term visibility architecture, is this resonating with the customers?
Yeah, it is to me, because again, they're talking about security architecture. Well, now it's visibility, and it's like, well, what do you mean by visibility? Well, it's simple, right? You need to see what's on your network, what's not on your network, and guess what? There are areas that are blind spots. Just like if you're driving a car, there's blind spots. You got the same thing on your network. There's areas where you just can't see. I mean, you may think your tools are covering it, but when you go in and you do a deep analysis, you're going to be shocked. Most companies that we've talked to, it's like, oh, I didn't know that was there. And that's where Tim and I have talked before. It's like, yeah, you put a tap in there. Don't use a span or something for all of your areas, but actually put some taps in some of these areas. You're going to get a copy of all the data and see what you're missing.
Yeah, it's funny.
The moment that we show what a visibility architecture is and how they can attach all their tools, it's a big aha moment. Then they're like, okay, I get it. This is what I need. But until you show that, I have to admit, sometimes the concepts can be blurry. The moment you show it, everybody gets it.
It's visibility it reminds me of when I'm at Costco and I'm driving at the parking lot and the car pull out, and I can tell when I see that it's a certain car. I mean, when I see that it's a car of certain age, and I know that they don't have a backup warning, which means that they don't have visibility, I would just stop right away. I'm not going to take any chances.
Exactly.
Yeah.
Are you talking about the last time I was at Costco, Denny?
Yeah, that was you, right?
Yeah, that was me. But it was also the speed. I mean, I drive fast, so I just shoved it in reverse and whipped out of there like nobody's business.
Hey, Keith, we have a list in the show notes for the viewers out there. We have a list of items that we want to cover. I wonder if you could give a summary of that, and then let's see how many of those we can hit today.
Okay, well, I mean, the first one was just talking about what is a visibility architecture. And then, so what is it? Well, there's really like 4 areas. The first one is the access. We talked about that. I think Rajep and Tim have both covered that with the taps and virtual taps and so forth. The second thing is to go in and filter the data set. And Rajep had mentioned that layer 2 through layer 4 packet data filtering. The next step is, do you need to use application level filtering? Do you need flow data for your different types of tools? What type of tools do you have there? And then the fourth level of the visibility architecture is the tools themselves, whether it's security tools, monitoring tools, are they application performance, network performance monitoring tools, are they diagnostic troubleshooting tools like Wireshark? Whatever it is, you've got a set of tools there, and they have certain requirements, and they're used at different points in time. Even if you say security tools, well, you've got some that are inline, that are like, your IPS and stuff. And then you've got others that are typically out of band, like the DLPs and the IDS and things like that. So you've got, and even the forensic analysis of data. So you've got to know what type of tools you have. But that's the basis of what we really want to talk about today. And I think we've done most of it. It's just there's those 4 different levels. You know, make sure you have your plan, whatever that is, that addresses all 4 areas.
I may make a comment. More and more companies are getting dragged into court because of issues, misuse of the network, people doing things wrong, whether or not they're just stupid or they're, they intentionally do it. If you go to a courtroom and you try to argue that I got all the data and therefore this person did this or did that or didn't do this and didn't do that, and then someone that is familiar with forensics in a network starts saying, well, you used a tap, of course, and the guy looks at you and says, no, we got it all span. Right away, it becomes a question because span can be hacked. Cisco's done a lot of work showing that. So have the black hats. So just to be on the safe side, if you're doing any forensics work at all in a network, you better use a tap because you have to defend that in a courtroom. Going to a courtroom and said, well, I got most of it. Well, the judge and the defense are going to drill holes in you. So if you're going to do anything like that, get a tap. And that way you won't have to, get yelled at by the defense.
Absolutely. And taps are extremely affordable, low cost, very simple devices. So you can insert these taps in your network, and because they're very simple, they last a long time and they don't cause any interruptions in your network. The mean time between failure is extremely high because it's a very simple device, right? So there's no issues. It's not like inserting a complicated device. And again, most of that monitoring fabric, whether it's tap, whether it's a virtual tap, whether it's a network packet broker, is designed through exhaustive testing to be extremely reliable, because that is the essential fabric. And once you deploy a visibility fabric, it makes it much easier to introduce new monitoring tools. That's one. It makes it easier to upgrade them with no interruption. It allows you to load balance data to your monitoring to your tools, and just imagine the extra level of security that get, because we hear about companies being hacked left and right. I mean, just imagine what happened with Yahoo when they were trying to sell themselves to Verizon. A simple hack cost them to lose $1 billion in valuation. Is it really worth it? And just imagine you were going to make $1 billion more, but you were very relaxed and lax about your security and visibility. And guess what? That cost you $1 billion. There's many more examples. Sorry, go ahead, Keith.
I was just going to say one more thing, piggybacking on what you said with the tap and the packet broker. One of the great things about using that combination is once you insert the tap, you put it into the network. So it's in the flow of traffic. After that, you never have to really interfere with that flow of traffic again. The packet broker can do the filtering of the data after that. So guess what? If you need to go in for fast troubleshooting, looking for breaches, things like that, there's very few change boards that often are required to get approval from to go in and look at the data. You're not touching the network again. It's already there. You're just taking a feed off of that tap. So your mean time to repair, your mean time to diagnosis can be orders of magnitude faster. We've actually had customers at Ixia that just by using that tap NPB combination, they were able to reduce their mean time to repair by up to 80%. And a lot of it, literally from like 5 days down to 1 day or less than a day, because they didn't have to go through the change board approval process. They could, they already had the NPB and the tap in place. They just filtered the data and then sent it to the tools that were already hooked up. They literally were able to save themselves a lot of time and a lot of money.
So Keith, I assume that NPB means network packet broker?
Yep. Sorry, I love acronyms. I should have worked for the government.
Okay, so that's good. That's good. I'm learning. So I want to go back to that. I want to, for those out there who might not be familiar with the term packet broker, I'm one of them. Even though I work on one of the first device, one of the first company, because it's a term not used by. It's a term, if I understand it right, used first by Gartner, right? Yeah,
Gartner coined the term.
Okay, fine, and they must be right. So explain to someone out there, one of our viewers who are not familiar with that concept. So you got your taps. That's what you call the fire hose, right? You finally get all the data you want, but it's coming in as a fire as if you're getting it from a fire hose. And you got your tools out there. And if I understand it right, packet broker is the middle, right?
Yeah, exactly. If I were to use that analogy, I'd really say, so you've got all your data out there. That's the water main. You're going to, for like a subdivision, you put a tap in. That gives you access to it like a fire hydrant. You still got this massive data coming out. You send that data over to the NPB. Well, with the layer 2 to layer 4 filtering, you can step that down from like a fire hydrant down to maybe the water main coming into your house. Now, if you go in and you do the layer 7 application filtering, you can step it down to the size of like a garden hose. So you take that massive amount, you step it, keep stepping it down, and then you're sending that smaller amount of data to your tools, and you don't overload the tool. And it also saves you a lot of times on the cost of the tool. You need less memory, less number of tools, and so forth.
Yeah, but it's not just it's not just stepping down, right? It's not just throttling down the data so that your tools can use it, but it's also about getting data from multiple fire hydrants so that you get a comprehensive view of the network, right?
Exactly. So that's one instance. Now you can really, if you extrapolate it, I guess you could say there were all these different fire hydrants all over the neighborhood. You've got all these different points throughout your network, whether it's central network or ingress, egress, wherever. You bring all this data in, you filter it as you need. You can actually do load balancing to multiple tools. So, you know, if you've got lower rate tools, maybe your network's running at 10 gig or 40 gig, let's say 40 gig, and you've got 10 gig tools out there, you can actually step down the data flow and send it across to multiple tools. Maybe 40 gig, you spread it over 4 10 gigabit tools. But then you can also filter the data to only get the critical amount of data you want and really refine that data, and you can step down the bandwidth to the tool even further.
Now, one of the things that people miss out there is the cost of training. If you've been using Wireshark or you've been using XYZ tool, and all of a sudden you've got to get a new tool to handle new data, that's a learning process. And that costs money. And it has to be retrained regularly. So when you decide to get a packet broker, that's a cost-saving thought, is that, hey, I don't have to buy new equipment. I can still use the test tools I'm familiar with and make them even more effective, like you were pointing out. And of course, you also want to buy a network packet broker that you can rely on, that you're not going to have to constantly send people in for training and misunderstanding stuff. So I'm sorry, Rajette, go ahead.
No, first of all, can you guys hear me? Because
yes. We can hear you. We can
okay,
hear you.
good. You know, ease of use is extremely important when it comes to being able to quickly get up to speed, decide which kind of data, what kind of flows, what kind of applications that you want to send to your tools, and that's why we love our NPVs, because they have a great user interface that really reduces the amount of training that you need. But there's much more to NPV than just filtering, because just imagine SSL. How about SSL decryption for all your tools? If you have tools, are all of them capable of doing SSL decryption? Because guess what? There's the amount of traffic that's being SSL encrypted is increasing. So you can use your visibility fabric to normalize the data for all your tools, right? Well, how about duplication? Now, if you're tapping everywhere in your network, it's possible that you're sending the same packet that is being detected by multiple taps to the tools. Guess what? You can do deduplication. And you can send probably up to 70% of your traffic and only send 30%, because guess what? The rest was going to be the same. Maybe some tools only need to look at the packet header. You don't need to send the whole payload. Well, you can do intelligent packet slicing based on the tool. And because of a great user interface, it's so easy to program your network packet broker. And guess what? This usability is very important, because one day when you're sleeping at 4 a.m., you get a call and there's something going on wrong. You really don't want to deal with a complex infrastructure to figure out what's going on, or how to do debugging. it's possible to use that. You set these filter rules or rules 6 months ago. You don't want to memorize all the commands. You want an easy to use interface, because you probably did, maybe it's possible that you can look at it for 6 months. But when you get that call at 4 a.m., you want to be able to quickly navigate and find out what you set up, what went wrong, and find the culprit and fix it immediately. So that user interface is extremely important, whether you use it frequently or infrequently.
Yeah, exactly. Just to piggyback on what you and Tim were talking about, usability will factor in heavily to your total cost of ownership. A lot of people, they want to focus on the upfront cost of the tool or something, but that usability, how fast can you use it? Is it intuitive? Is it just drag and drop, click and so forth? Or do you have to go in and write lines of text, use Boolean algebra, things like that? And then do you have to go after that and validate what you've got from the output? Or is it simple and easy? Especially if you go in and you're programming your data flows, or your packet data or your data flows on a monthly basis, like 2, 3 times, 4 times a month, like I've seen in some of the industry studies, that starts adding up, month after month, year after year. That usability or lack of it is going to cost you money.
Mm-hmm.
Yeah, I always tell people when they're trying to evaluate a product, of course, my motto is don't trust them, test them. And, if someone walks in and hands me a packet broker and says, we got to look at this type of data, like Rajette was talking about, I don't want to have to sit there for 3 hours, 3 days, trying to write CLI that I can't test. I can go in and just say, well, just click on test ABC number 4. And bam, there it goes. You don't have to do that. And again, that gives you a lot of confidence, because you've got a tap, you're getting all the data. It adds that confidence factor. When I was at Network General in Clearsight, I calculated how long it took an average analyst, someone that's knowledgeable, to follow a TCP IP stream, and it ran to be about 2 minutes per packet. So you think about how many packets you're going to get hit with at 100 megs. 100 gigs. And if you don't use a qualified quality tool to filter them, you're going to die still trying to analyze 1 days of data that you got 40 years ago.
Well, we're coming up on the half-hour mark. So I want to kind of slowly wrap this up. But I want Keith and Rajep to kind of touch on 2 things. I want to talk about the other 3 installations that we have in mind, besides this one, that kind of lay out all the best practices for network monitoring. But before we do that, one thing that catches my eyes among some of the features of the MPB is something called deduplication. Keith, can you explain that? Why is that important?
Yeah, so what happens is, especially with the use of span ports and stuff, you're going to get duplicate packets that are going to get created on your network. It'll come into the network switch, and based upon what happens, where it's the data is captured within the network switch, it's going to get routed to an output port called a span port. And typically you've got incoming, outgoing, and you've got bidirectional. So you typically end up getting multiple copies of the data. You can also have malfunctioning equipment in the network that could be generating multiple copies of the data too. But this duplicate data, if you pass it straight on, you don't filter it out, it's going to hit the tools, and then it's going to cause your security tools and monitoring tools problems, because they're going to see the data once, see it twice. They're going to lose track of what it is, or I should say the original source of the data, the timing on it, and stuff like that. So deduplication removes it.
Exactly, right? Especially, a number of protocols have handshakes, and it has to go in a certain order. Well, if you get 2x back to back or 2x back to back because of the nature that we're tapping, that tool is not going to get the beginning of the conversation, and now it's not going to recognize that whole connection. So that's just one to elaborate on key point there.
Yeah, exactly.
Can
Yeah, when
actually,
people tell me they're buying
I can. Can you guys hear that okay? Because I can't hear that well. Maybe Keith can kind of summarize some of the main point that Jeff just talked about.
Or I think Tim was actually going to comment on it, right?
Tim, go
The
ahead.
comment I was going to make is a lot of times people say, well, I've got a deduplicator in my device. I'm like, well, do you know if you don't have duplicate packets? If you have duplicate packets, duplicate paths, you need to correct them before you deploy a device that actually could mask a very major problem in your system. So if you're going to deploy a dedupe, first off, make sure you got a quality one, but also make sure you've tested the network to make sure you don't have duplicate packets. And Rajet's point was around that, making sure you have that capability.
Yeah, exactly. I think Rashep was saying too that so if you get the packet coming in, the security tool is going to do an acknowledgement that it got the packet and the information. But if it sees multiple copies of it, that tool is going to have multiple acknowledgements, which is then going to confuse the tool. It's going to open up multiple sessions, which consumes more memory in the tool. And then it's got to try and resolve at the end, well, which one of those sessions was actually legitimate? Are they all legitimate? And it just gets to be a mess, and you end up missing things.
But I want to go back to what Keith said earlier about deduplication, and I want to make the point that when we talk about visibility architectures, we're really talking about three different things. We're talking about the access, right, which is the tabs or the span ports, which is where you get the packets into your monitoring network. Then you have your monitoring tools on the other side, and the NPP is what's in the middle, and together is what we call visibility. Is that true, Keith?
Yeah, that pretty much sums it up. I mean, you've got your access, your filtering, and then your tools, and the three together.
Yeah, and I want to make sure that the viewers out there understand that even though we talk very passionately about tabs, tabs and span ports and NPP, they can all work together. I mean, there are just times when you have to get data from the span port. Maybe not exclusively, but that's just how you're going to have to augment it. And I think the point that Keith made, if I understand it correctly, is that in that situations, the NPP would still help you, right? It would still allow you to clean up some of the data before you feed it to the tool. I don't know why I keep having this image because because I'm going to Japan soon. And one of the things that I love to do in Japan is to enjoy what they call the onsen, which is the hot spring. And when you're in that onsen, you're in that pool of water, the water coming out from one place. But if you ever go to the back, you just see this wonderful, wonderful artwork of plumbing, and some of which are probably a couple hundred years old, all made of bamboo. And what they're doing is they're not just throttling the water that comes from the volcano, but they're actually mixing and matching so that you get the right temperature and the right mineral composition. And I think that's the image that I get when I hear Keith talking about the visibility architecture. The taps are where you get in the water. The tools are basically the guy sitting on the top. And the NPP is in the middle that is doing all the customization, right?
Oh, that's a very good analogy. In fact, I feel relaxed just thinking about that.
Yeah.
Well, first thing I think about is my bank account, right? If someone only gave me half of the information about my bank account, I definitely would be afraid. So you want all the information. And I'm a big, some people jokingly call me the tap preacher, but I certainly believe that getting real data, understanding how to filter it correctly is paramount.
I think of you as a tap enforcer because you're meaner than a preacher. Why don't we wrap this up? And so Keith, go back and so give us a taste of what's to come. So we're laying out the visibility architecture today.
Yes.
And what more what other stuff that is coming up?
Well, for the next one, it's like, okay, so now you know what a visibility architecture does for you, but what can you really do with it? So we were going to explore more into the different solutions. So we'll talk about deduplication. We'll talk about SSL decryption. We'll talk about high availability for inline tools with bypass switches and high availability in packet brokers and stuff. And so really it's the next level. What can you do with that? And then there'll be some future sessions after that talking about application performance and network performance monitoring, specifically in general, optimizing your network. How do you go about it, and using visibility to help you do that?
Good. Very neat. Very neat. And
one point I was going to bring up is now, Keith, is there a place that people can go read more about this on the IXIA?
Most definitely, yeah. We have all sorts of materials on ixiacom.com. So that's IXIACOM.com. Go to the resources tab, and there's best practices on network monitoring. There's a white paper there on that, a best practice on deduplication. There's actually a new ebook we just put out on the ABCs of network visibility. That's sort of like a dictionary or a lexicon of different visibility terms. So to Denny's point earlier, what is network visibility? What is the visibility architecture? What are blind spots? Go check out the ebook. It tells you all about it right in there. What it is, some use cases, and then some things to consider when you're putting your architecture together.
And Rajab, I love having you on the show. And so before we do the next one, we need to figure out how to get you better bandwidth.
Absolutely.
Yeah. I know a few people who knows that kind of stuff.
Yeah, if we just had some people in IT, that would really,
if we
really
only
help,
know
right?
that,
Yeah.
Okay,
yeah.
well, with that, we'll thank you for watching us. And Tim, you want to close the show?
Well, first off, Rajed, if you want me to come to Austin, I'd be more delighted to find out your problem. But I think it can be solved by an adapter and about a 10 or 15 foot cable. But I Keith will tell you this, and so will Jet. When you're involved in just management of a network, visibility is critical. You can use a span port for a few things, but when you start looking for security events, real-time events, no hackability or non-hackable, however you want to say it, get a tap, get a good one, and get the data. And when you get the data, then you'll be able to deploy your knowledge about how to filter it, how to hand it off to Wireshark, Nmap, to other systems. And then, and only then, you'll be considered a hero, because you'll be able to see things that nobody else has ever seen. And, questions are what cause us to move forward, not answers, but the questions we can ask about our network is what we do to learn. So get a tap and see what you can see. You'll be amazed.
Thank you, Tim. And thank you, Keith.
Thank you.
Thank you
again. And thank you, Rajab.
Thank you.
And with that, goodbye, and we'll see you next time. Bye-bye. Thank you for joining us.